first problem here, an 18-kilogram child sits 1.5 meters from the pivot point of a weightless seesaw. How far away on the opposite side should his 40-kilogram mother sit if she is to balance him? So, pinakauna ka, you need to draw the free body diagram for this system. Okay, masayon siya mag-draw kay nga no, nara sa figure tanan or nasa system tanan ng mga forces. Di parehas sa Newton's laws pag-draw og free body diagram. So, it is assumed nga weightless ang seesaw, so di nyo may consider ang weight sa seesaw. So, there are two forces lang involved. That would be the weight of these two persons nga nasa seesaw. So, here, kay weight coming from the child, we'll call this one as F1, which is simply equal to M1G. And here, the mother, we'll call this one as F2. Okay, F2, which is equal to M2G. And also, we will call this one as moment arm R1 and the other one as moment arm R2. So, ang variable nga gipangita is how far away. So, meaning to say it's asking for the value of your moment arm R2. Okay, so here, since the whole system is in equilibrium or balance, so meaning to say na duha ka conditions for this one, summation of forces is equal to 0 along x, along y, along z, and summation of all the torque is simply equal to 0. So once mag-solve mo ging ani, you need to remember these two conditions and then ang sign convention atong torque. Kano sa siya positive, kano sa ama negative, and kano sa ama 0. So here, we're going to use this one. Kaya nangita man siya moment arm. So summation of all the torque is simply equal to 0. Naay duha ka torque due to two forces. One torque due to force 1, and I'll call that one as T1, plus T2 or torque due to force 2. And then equate that one to 0. Ang equation sa torque ay RF sine theta man, so R1 F1 sine theta. So here si F1 kung ano yung pivot, kung kanila nga force ang ga-exist, ang rotation kay counterclockwise. So meaning to say, positive. And then ang angle between the moment arm and the force is simply equal to 90 degrees. So you'll have here 90 degrees. Next, for torque due to force 2, pivot point, F2, kung kanila nga force ang ga-exist, ang rotation kay clockwise. So meaning to say, negative, so minus, you'll have R2, F2, sine, the angle between moment arm and force F2 is simply 90 gihapon. So you'll have here 90 degrees. And then equate that one to 0. So next is that we'll have to solve for this variable here. So add this whole expression both sides. So the whole equation would look like this. R2 F2, since sine 90 is simply equal to 1, sine 90 is simply equal to 1. So which is simply equal to R1 F1. So we have to substitute ang values sa mga forces. So you'll have here R2 is simply equal to M2G, rather ang F2, which is equal to R1 times M1G. Yes, naay common nila, and that would be your G, and the unit sa imuhang kilograms sa imong mass. So divide both sides by M2, so imong R2 is equal to R1 M1 over m2. So, ang value sa moment arm R1, that would be 1.5 meters. Ang mass 1, 18 kilograms. And then you'll have here all over mass 2, which is 40 kilograms. Again, I repeat, ang unit sa mass can mag-cancel out. So, you'll have your R2 is equivalent to, it must be less than 1.5 kay bugat man ang mother. So, that would be equal to 0.68 meters. Second problem here, a mass of 20 kilograms hangs from the end of the rod of length 2 meters, and the length of this rod is 4 kilograms, and a wire attached to the end of the rod and to a point 1 meter above point O. Find the tension in the wire and the force exerted by the hinge onto the rod. So, ang tendency is that first things first is you need to draw a free body diagram for this case in order to determine what are the forces nga naa sa system. But then, the only thing advantageous mag-draw og free body diagram is that naka-attach lang ang mga forces nga na within the system. So, here, for this case, kinamay cable, so meaning to say na tension. So, at this point, here, tension T. Okay, next, I weight sa imuhang signage, so downward. Here, we'll call this one as W, weight sa signage, S. So, it is understood nga, same lang ang kaning tension o kaning WS equal lang. Next, since given ang mass sa rod, and it is assumed to be a uniform rod in such a way nga ang ihang center of gravity is located at the center, at the middle, so nasa 1 meter, nadira yung imuhang weight sa rod, and we'll call that one as WR. And ang next is simply kini, this will be assumed as the hinge. So here, tawagon natin na siya hinge or your pivot. So, force exert ang hinge onto the rod. What are these forces? So, ang tendency is that kining ang mga forces kay una, since wall, and then na-attach ang imuhang horizontally imong rod, so meaning to say normal force here towards right. And tawagon na to siya Fx. So, horizontal force exerted by the hinge onto the rod. And also, to keep this side sa rod from falling, so mean to say, we need an opposing force in the form of friction. So, di lang friction atong tawagon sa iha, but rather Fy. Okay, so there are 1, 2, 3, 4, 5 forces. So, take note that the whole system is in equilibrium. So, ang tendency is that from the two conditions, summation of torque is equal to 0. Or the second condition, it is simply summation of forces along x is equal to 0. And the summation of forces along y is equal to 0. So, here, kung i-add na ko ang mga forces, tanan, regardless along x and y, you'll notice walay tension, walay horizontal and vertical force nga gi-exert. So, meaning to say, kaning duha ka condition diri, kaya di pa na ako magamit. So, in order to find the tension, is simply magamit ko ani nga condition. Summation of tanang mga torque is equal to 0. Okay, so here you need to define your hinge. So, most likely, pwede ka maka-hinge diri, pwede ka maka-hinge diri, pwede ka maka-hinge dira. Anyway, i-sum na nimo ng torque that is simply equal to 0. Pero ang pinaka-best maghimog hinge or mangitag hinge is ang point nga daghag unknowns. So, kani nga point O, kay daghan siyag unknown, so most likely, para makita na to ang tension. So, most likely mo na itong gamiton. So, ang tendency is that here, i-add ang tanang torque due to that forces, 5 forces. Torque due to the tension, plus ang torque due to the weight sa signage. and then torque due to the weight of the rod, plus ang torque due to the horizontal force sa hinge, plus ang torque due to the vertical force sa nag-produce sa hinge. So, ang tendency here is that na mag-zero, nga term, ma-zero na sila, it's because ang moment arm is simply equal to 0. Okay, next is simply apply na to sign convention. Take note from the sign convention mga bata nga kung counterclockwise, positive nga torque, o kana nga force maka-cause og clockwise nga rotation, meaning to say negative na siya nga torque. And ang equation sa inyong torque is simply equal to RF sine theta. Magnitude of the moment arm, meaning to say, ikan sa pivot, paingon sa asa ang force, and then ang force, and then ang angle between the moment arm and your force. Okay, so here, muna sa tension, no? Kung rotate ning kaning tension, nadri ang pivot, so that would be counterclockwise. Positive siya, so meaning to say you have positive torque due to tension. Next, your WS. So if you'll notice, na ang hinge, and then na ani, so that would be clockwise, so meaning to say you'll have negative torque due to the weight of the signage. And even ang weight due to the weight of the rod, torque due to the weight of the rod, so you'll have negative kay clockwise. And then equate that one to 0. Move these two variables to the right side of the equation. So ang tendency is that here you'll have torque due to the tension is equal to torque due to the weight of the signage plus ang torque due to the weight of the rod. So again, kini kay gi-add pa rin ako ha, wala pa sign convention gi-apply. Sa diri ana dayon nga part gi-apply ang sign convention. So here, ang equation sa torque kay RT man ano, so you'll have moment arm sa tension, ang tension force sine the angle between the moment arm, kani nga moment arm, and your tension P. So, a tendency is that to look for your angle theta, so ang given lang, if you'll notice, is the opposite side, 1 meter, and the adjacent side nga, 2 meters. So OA, so TOA, so you will use tangent function for that one. Tangent theta is equal to opposite side, which is 1 meter, divided by its adjacent side, which is 2 meters. So your theta, tangent inverse 0.5, that is simply equal to 27 degrees. So therefore, here, this is simply equal to sine 27 is equal to, you'll have moment arm, WS, and its weight, sine, okay, the angle between your moment arm and your WS, that is simply equal to 90 degrees. And then here, plus the moment arm sa imong rod, and then weight sa rod, and then sine the angle between the moment arm and your WR, that's still equal to 90 degrees. So here, take note that sine 90 is simply equal to 1. Sine 90 is simply equal to 1. Divide both sides by the moment arms, attention, and your sine 27. Okay, so you'll have here RT sine 27. So, mag-cancel out. So, you're left with a term nga, tension T. So, let's substitute the given value. So, you'll have here T is equal to the moment arm, meaning to say distance gikan sa pivot, paingon sa WS, that would be 2 meters, times ang weight of the signage. So, if you'll notice, mass ra gihatag. So, all you have to do is to calculate for its weight. So, multiply 9.8 sa ilang mga masses. So, na kay 20 times 9.8 meters per second square. That is equivalent to 196 newtons. And the weight of your rod, that is simply 4 kilograms times 9.8 meters per second square. That is simply equivalent to 39.2 newtons. So here, weight of your signage, that would be 196 newtons plus the moment arm, gikan sa pivot, paingon sa WR, that would be 1 meter halfway. So you'll have here weight 39.2 newtons. All over ang moment arm, gikan sa pivot paingon sa tension, that would be 2 meters. And then you'll have sine 27. So the tension is simply equal to 475 newtons. Okay, so that is the tension of the cable. Okay, next is that it's asking for find the force exerted by the hinge onto the rod. So meaning to say it's looking for Fx and Fy. So this time, kaning nga mga conditions atong gamiton, summation of forces along x and along y is simply equal to 0. Next, i-evaluate kung naay mga forces nga wala galay along x and y-axis. So ang tendency is that by convention, take note that kaning nga direction, we'll assume that is a positive y, opposite ana kay negative y. And pa right is a positive x-axis, opposite to this one, that would be negative. So here, ang tension mo ay wala galay along x, so all we have to do is to use component method. So mag-draw ka dira og arbitrary nga positive x, positive y. So na kay tx towards left, and then ty, which is upward. So one tendency is that mangitatag components, so if you'll notice, your tx is on the adjacent side of your angle theta, angle 27, so meaning to say that's cosine. So ang tx is simply equal to 475 newtons cosine 27, which is equivalent to 423 newtons. And your Ty is simply equal to 475, opposite man to no? So you'll have sine 27, so you'll have 216 newtons. Okay, so if you'll notice, wa pa na gibutang ang negative diri sa tx, ang mga signs. It's because ayhan ako sa ibutang the moment i-add na ako tanang forces along x and y. Kay masayop man kung ma-redundant siya kung mag-negative ko diri, and then the moment i-add na ako mag-negative. So mo-plus siya. So next is that summation of forces along x is equal to 0. I-add ang mga forces na nasa x-axis. So ang tendency for this case, nalay do ka force, Fx towards right, so positive, and then your Tx, which is towards left, so meaning to say negative. So take note, kani nga summation of forces is different aning Fx. Kani nga Fx kay horizontal force exerted by the hinge onto the rod. Kani siya nga Fx kay summation of all the forces along x-axis. So here, so you'll have here Fx minus Tx is simply equal to 0. So move this Tx to the right side of the equation. So your horizontal force sa imuhang exerted by the hinge onto the rod is simply equal to the horizontal or the x component of your tension, 423 newtons. Next, summation of forces along y is simply equal to 0. So upward or downward ng mga forces, so you'll have here Fy upward, Ty upward, and then Wr and Ws are simply downward. So meaning to say you'll have here Fy plus Ty minus Ws minus Wr is simply equal to 0. Therefore, your Fy is simply equal to, move this 3 to the other side of the equation, so you'll have Ws plus Wr minus Ty. So you'll have here Ws 196 newtons plus 39.2 newtons minus 216 newtons. So the answer is simply equal to 12.9 newtons. Okay, so to look for the magnitude, all you have to do is to use Pythagorean theorem. So you'll have here summation of forces along x, then squared plus Fy squared. So ang tendency is that you'll have square root of 423 Newton squared plus 12.9 Newton squared. So the answer is still equivalent to 423 newtons. So kasabot-an is that majority of the force kay dako exert ang horizontal compared to the vertical force nga nasa hinge. Third example here, the system in the figure is in equilibrium. A mass of 225 kilograms hangs from the uniform strut whose mass is 45 kilograms. Find the tension in the cable and also the force exerted by the hinge onto the strut. So here, again, I repeat, you need to draw a free body diagram for this case and then take note that the length of this strut is not given, so it might be mag-cancel out lang. So here the forces that are present are the following. You'll have the weight of this box. Okay, so we'll call that one as WB. Next, the tension here, kining a tension, T. And also ang weight sa strut, since it is stated nga uniform, so meaning to say midway, halfway, ang yung weight sa strut, we'll call that one as WS. And next, sa hinge. Okay, so here. So, to, since na may floor, so meaning to say na normal force, and we'll call this one as Fy. And to prevent the strut from moving left, so we need an opposing force in the form of friction. So, ang tawag dito sa yakay, Fx. Okay, so here, also we need to note some important given. Mass sa box is given by 225 kilograms, and the mass of the strut is equivalent to 45 kilograms. So basically, in solving for its weight na lang ahead, so 225 kilograms times 9.8 meters per second squared, mg lang na equation. So you'll have here 2205 newtons. And this one, 45 kilograms times 9.8 meters per second squared, that is simply equal to 441 newtons. So basically, we're looking for the tension in the cable. So ang tendency, this will be our hinge. Okay, so ang next is simply we're going to use the first condition sa in equilibrium, summation of the net torque is simply equal to 0. So meaning to say torque due to WB plus torque due to the weight of the strut plus ang torque due to tension T plus ang torque due to Fx and Fy. Pwede na din ninyo ni-include ning doka term because it is understood nga equal siya sa 0 ning duha. Kaya ang moment arm is simply equal to 0. Okay, so next is simply by using sign convention. So WB is pivot or hinge. WB causes a clockwise rotation, so you'll have negative WB. And even your weight sa strut causes a clockwise rotation, hinge, and then here. So you'll have here minus the torque due to the weight of the strut. And then you'll have positive, right? This is the tension. So as it rotates, it causes counterclockwise rotation. So torque due to the tension, which is simply equal to 0. So it's looking for the tension. So remain siya sa left side sa equation. And all we have to do, aning duha, is to move this 2 on the right side. So making it positive. So T, which is simply equal to positive torque due to the weight of the box, plus ang torque due to the weight of the strut. So substitute, ang equation sa torque is RF sine theta. So you'll have here R T, then the tension T, and then sine, the angle between your tension T and your moment arm. So kini nga angle mga bata, here, okay, kana siya nga angle. So if you'll notice here, 145 or 180 minus 45, that would be equal to 135. And also, kining whole triangle is simply equal to 180, so 180 minus 165, that is simply equal to 15 degrees. Okay, so I mean to say this is simply sine 15, which is simply equal to the moment arm, sa imong weight B, WB sine the angle between your moment arm and your WB. So if you'll notice this triangle here, so it's simply 90, 45. So 180 minus 90 minus 45, that is simply equivalent to 45 degrees. So I mean to say this is also equivalent to 45 plus moment arm ni WS ang weight sa strut, and then you'll have sine 45. Ano, 45 man, this is simply a smaller triangle nga version kaganina. Again, 90, this is also equal to 45. Okay, and then all we have to do is that we're looking for this tension T here. So divide both sides by RT sine 15. Okay, so you'll have here RT sine 15. Okay, so next is simply cancel out. So your tension T is equal to the moment arm. When to say distance gikan sa pivot paingan sa WB and it's not given. So basically we'll assume that it's L ang length sa strut, L, WB sine 45 plus, okay, so you'll have here RWS, that's midway, so that would be L over 2, and then the weight of the strut, and then you'll have sine 45. Okay, all over again. Moment arm, pivot to tension, ang distance is L, sine 15. So there's a common factor there. So all you have to do on common is sa numerator is L sine 45. So you'll have here quantity WB plus WS over 2. So you'll have here L sine 45 all over L sine 15. So basically, mag-cancel out ang L, length L. So ang tendency is that you'll have your final answer, substitute all the given answers, so you'll have here 2205 newtons minus, I mean, plus 441 over 2 newtons. Then square root of 2 over 2 manang sine 45 all over sine 15. So the tension is simply equal to 6,630 newtons, or equivalent to 6.63 kilonewtons. Oh, next is to look for the force exerted by these by the hinge onto the strut. So we're looking for Fx and Fy. So again, we have to use components for those component method to those forces nga wala nakalay along x and y. So if you'll notice the tension, yes, so we need to look for its x and y components nga dx and then dy. So I have to make an arbitrary axis positive x diri and then positive y. So it could either be you'll use 60 degrees, 45 plus 15, or this 30 degrees here. Okay, 30 man ni, parallel lines man ni sa kini nga side o kini nga side. And then na intersecting line, so alternating angles are equal. So kani 30, kani po siya 30. So ang tendency is that na kay tx, right? This will be your tx, and then downward, this will be your ty. Okay, so if you'll notice, it's on the third quadrant, so negative both. So I had na incorporate ang negative sign pag mag-add na ko tanan. So we have to look for its x and y components. So you'll have here tx is equal to 6,630 newtons. And then you'll have cosine 30, which is equal to 5.7 times 10 to the 3 newtons. And your y component is simply equal to 6,630 sine 30, and that would be equal to 3.32 times 10 to the 3 newtons, or can be written as 5.7 kilonewtons and 3.32 kilonewtons. The next step is to, yes, add all forces along x and along y. So here, add all forces along x, that would be equal to 0. So there are two forces along y lang, that would be your fx, which is towards right, so positive. Kaning ex is negative towards left. So equate to 0 then. Pagkahuman kay transpose to the other side of the equation, so your fx is simply equal to your dx, which is also equal to 5.7 kilonewtons. 5.7 times 10 to the 3 newtons can be written as 5.7 kilonewtons. Okay, next is simply add or all forces along y and then equate that one to 0. So basically there are four forces, 1, 2, 3, 4. So all are downward, ang T downward, WS downward, downward, except for Fy. So mean to say you'll have Fy positive minus T minus WS minus the weight of the box is equal to 0. So therefore, your Fy is simply equal to T plus WS plus WB. So nakay 3.32 times 10 to the 3 newtons plus 2205 newtons plus 441 newtons. So that would be equal to 5.97 kilonewtons. 5.97 kilonewtons.